So my guest today, normally my guests are a fair bit smarter than I am, and yeah, today is no exception. I had the privilege of working with this person about 8 to 9 years ago, when we were both working at Hydro Tasmania. It might have even been longer ago. Since then, he's been involved with some really interesting technology over the years across generation, distribution of electricity, and other types of technologies. He's also been involved in the installation of Australia's first proper utility scale battery. These days, he's the head of energy for the Australian division of one of the world's biggest rolling stock manufacturers and also energy storage developers. It's great to have David Butler on the show. G'day, David. How you doing?
Yeah, great. It's really nice to be here. Thanks for inviting me.
No worries. And I know you just come back from a couple of days in Adelaide at the Impact Live conference. How was that?
Oh, it's an excellent conference format. It's just a small number of people who are really passionate about their things and covering lots of different elements of sustainable manufacturing.
Brilliant. And it's quite a bit of that in Adelaide and South Australia. A surprising amount of innovation and actual manufacturing happening on the ground too.
Yeah, and also a lot that's been enabled by the really large amount of renewable energy that they have in their grid.
Yeah, that's right. Hey, before getting into your career, which spans a lot of really interesting areas across renewables, can you remember when you were growing up? Did you have any particular thoughts on what you wanted to be when you grew up? Was it to become an engineer or be in the energy space, or was it something else?
That's a good question. So I guess the way that I chose my career probably is a good indication of how I think. I went through the entire list of courses that they offered at uni. I knew I wanted to go to uni and just crossed everything out that I didn't want to do. And at the end of that list, at the end of that process, I had a list of environmental science, architecture, and engineering. And the science side of it and the practicality side of it just made me go into engineering. It turned into mechanical engineering.
Gotcha. I think I had almost the exact opposite experience when I picked mine. I think I'd finished high school in Sweden, knew I wanted to go to uni, but I didn't know what I wanted to study. No one in my family had been to uni. And so I just figured I'll work for a year, then see if I can know what I want to do. Then I went overseas, did a bit of traveling, still didn't know. So then I looked at the list and I was like, what's something that's a little bit more general in nature that I can then build on over time? Because I really didn't know what I wanted to do. So I went for, okay, Bachelor of Business, let's go for that. That's a good start. And then as that went on, they introduced a major in sustainability, which is where I really went, oh, this is where I want to apply myself in the future. So quite a different approach there, but it seems like we both did all right in the end. And I know too, that like after you've done engineering, I've read up a bit, and I don't know a lot of people that had a PhD in artificial intelligence. How did you come about getting involved in AI? And I guess too, how have you seen AI change over the years? And perhaps for us normal people, we're probably only really starting to understand or actually see the impact on society over the last few years, but you probably have a completely different take.
Yeah, I actually stumbled into AI. So I don't know if people understand the history much of artificial intelligence, but the mathematics behind it was actually developed roughly in the 70s. So as a concept, it's been around for a really long time. And the thing that made it not practical then was computing power. So when I finished my bachelor degree at the University of Tasmania, essentially the theory was that computers had got powerful enough that AI could actually do something. And the university had a few years of it putting some thought into how they would put research into that. And the AI part of my research was really just driven by, okay, we've got these what felt like powerful computers at the time, what can we do? And the neural networks then were maybe 100 neurons, and it would take quite a long time to train, and figuring out exactly how you use a neural network was the hardest bit. But we also had to program them from scratch because no one had actually developed anything like that. So there was that side of things. But it wasn't like I just sat down and said, I want to do artificial intelligence. I was actually, at that time, it was very hard to get a job as an engineer. So I was faced with this prospect of getting probably a job I didn't want or hanging around at university and doing a racing car project.
Yeah, okay, yep.
So most of my master's degree was really focused on the racing car project.
Yeah.
We basically got our income for that project by doing the artificial intelligence work. So that's how the research grants worked.
Wow.
And,
Okay.
and that was a great project. I learned so much in that. It was with an awesome team. My supervisor, Vishy Carey, was excellent at pulling everything together. And we traveled the world with it. So like I raced in the UK with a German team, and I helped with another Denmark university over there for a few months, learning more AI stuff with them. My PhD evolved really into the artificial intelligence side of things. So a real focus on kitting out a car with lots of sensors and making sure we were using AI in an efficient way, which turned into a hydrogen project as well. So that's a different story.
Yeah, cool. Yeah. And I think that into having that sort of applied learnings and developing learnings in that sort of team environment probably helps you learn and get a lot more involved and probably build relationships for life, I would imagine, from that team. Yeah.
Yeah, we really pretty much lived with each other for a year, like constantly in the engineering lab building stuff. And it wasn't just sitting behind computers. We were actually using all of the tools in the workshop to make all of the parts for the car as well. It was a big project. I guess looking forward on the AI stuff, it's a bit hard actually to see the connection, because what I was doing was very much in the early days of how you build an AI, whereas everything now has really changed to a few large corporations doing that side of things, and it becoming more about how you use it. And the real thing that's enabled that is the horrendous amount of computing that goes into it.
Yeah.
But also the data sets, and it's actually the data sets that are the biggest enabler. So back then when I was doing my PhD, a lot of time went into cleaning data so it would work inside the AI. But it's different now. You've got a lot of data that you can feed it, and that's what's enabling all these new use cases.
Yeah.
But the most interesting part of the biggest the overlap between the two is that it's how you feed the data to the AI that makes all of the difference. You have to be really clear on what you want the artificial intelligence to do.
Yeah.
And that is a very difficult process in itself. And then finding all of the information that you think is important to getting that output. And normally you've made some pretty big assumptions, and it's hard to know exactly what that is. So testing it out and bringing it right down to what's important.
Yeah. And it's super interesting that thing. We recently watched the documentary series by Bill Gates on Netflix, which covers a few different areas. One is specifically on AI and the future of AI. It's super interesting. There's one on renewable energy and a few other ones too. I think they was released a few weeks ago. But it's interesting, that concept of the amazing thing about us humans, that we're across all the different fields or ways of being intelligent, we are pretty decent at many different things, whilst the large language models used today, they normally have like this niche, but like they're super smart and really well applied in specific areas with specific expertise. And I guess that's the thing, is that we're starting to get more and more of these niche areas. And I guess the interesting thing is when is that turning point where that can be applied across the whole spectrum of intelligence that we see as humans. And that's all seems pretty scary and dramatic to a novice like me. What are your thoughts of the future? Is it scary, or is it all opportunity and is good vibes? So what do you reckon?
It's a good one. Firstly, just on the mechanics of that, like we are starting with these really narrow models. If you take the neural network architecture to its full extent, those models should start talking to each other, and then having an overarching model which actually produces that more generalized system. So I don't think that would be very far away, and particularly the amount of data that they'll have access to is going to be very much of an enabler. The way it's used is obviously super important. So it just comes down really to the organizations that are using them and how they intend to use it. So there's some excellent use cases that I can see of just essentially even just organizing people. You know, there's a huge amount of work that goes into making these individual intelligences in humans work together and produce something that's greater than the sum of the parts. That's a lot of human effort, and AI would be excellent at solving those sorts of problems, which is an area that we haven't really put much focus on yet. But obviously that can be used in a different way. So it comes down to how that model was actually designed and what it's trying to optimize. And that's really the key, what it is trying to optimize. So if it's, for that particular example, if it's trying to optimize people's well-being, that will have a very different outcome if it's just designed to optimize profit.
Yeah, totally. And it's interesting, is in the last, say, week or two, there seems to have been some pretty big changes happening at OpenAI. I've seen they've started to take some shifts in their approach. Obviously, from the very beginning, they were aimed to be not profit, all about doing good, having ethical application of AI technology. And I think I've just seen in the last few weeks, they've gone and now we're going to become a for-profit company, absolutely. And I see both their CTO and their chief research officer are both left the executive team there. So it's interesting. It'll be interesting to see how that evolves, because I think that really needs to be some fairly, good guidelines in place for, I guess, both how these models can be used, but also, I guess, where having the ability to shut them down or limit some of the ways in which they can perform actions.
Yeah, and it really comes down to the boards of those companies saying, this is what our company stands for.
Yeah.
And we are going to potentially sacrifice some profit to be a good company and do these things which our customers and our stakeholders will value as well.
Yeah.
And that is a hard choice, though, especially in the environment we're in now. Money is very important in decision making, and it's very hard to predict, and it's getting harder.
Yeah.
So it's easy to focus on the immediate problem, and that's normally, how can we make our company more, or our business more sustainable from a business point of view rather than a social point of view.
Yeah. It's also super interesting, I think, that this sort of, I guess, interaction between energy and AI, it seems like we're really starting to have a bit of a race to build electricity generation in order to power all the new data centers that are coming on board to support the infrastructure for AI. That must surely be a pretty big opportunity for us companies in the energy space.
They're part of just the wider trends. There's a huge amount of electrification that's just starting to hit the grid. Data centers are a big energy user. So are electric vehicles. So is replacing gas and petrol and diesel and coal with electricity. So when you look at the numbers, it's somewhere between a doubling and a tripling of demand over the next 25 years.
Yeah.
But when you look at the scale of it, it's astronomical. And the only thing that really makes it easier is the distributed solar, because you can produce electricity nearby to those loads. But other than that, it's a massive transformation.
Yeah, no, it's super exciting. And I think a lot of the time it's easy for us, even in the industry, to think about the transition of replacing what's coming out, being called generation, with new renewable electricity, but we're also, of course, significantly increasing the demand across the grid. So it's, I think a huge amount of opportunity. Hey, early in your career, and as I mentioned before, you and I worked for Hydro Tasmania. I worked on the mainland for Momentum Energy. We worked for Hydro Tasmania down in Hobart and Tasmania. How did you end up landing at Hydro Tasmania back in the day? And can you tell us a bit about some of those projects that you were exposed to when you were there?
Yeah, it was another one of those examples of crossing things off a list. Essentially, when I finished my PhD, I was looking for opportunities. It was still hard to find work around the place, especially with a PhD, seen as something that just showed that you didn't like to work. So most people would say, I would consider employing you, but you have a PhD. It's a little bit different now. But essentially, I had two options. One was I had a job offer to teach at a university in Kuwait, paid very well.
Okay.
And I had a job offer at Hydro Tasmania as a casual graduate student, just to do something. And that offer came because Hydro Tasmania was sponsoring the hydrogen research that we were doing at the university as part of the projects that I was managing. So that's essentially how I got it to Hydro Tasmania development section for a long time. When solar was new, so we were investigating all of the different parts of solar and solar thermal and all of those things. Yeah, so that's how I started. It was a great little team there, and it's essentially I looped back right to that team just before I left Hydro Tasmania. But yeah, hydro work, so maintenance work with hydro assets. Then I moved into the wind sector, so I did a lot of consulting for wind work when wind was starting to be mature in Australia. We were just starting to get good systems to design wind farms and produce energy estimates and things that were important to develop projects. Then finally got into the microgrid work, which was where I really found my feet. So that was King Island back in the start of 2011. That island is amazing from a power system point of view. It's been where Hydro Tasmania has tested all of the new technologies for a really long time. So I think it had the second wind farm in Australia. The vanadium redox battery that went in shortly after that was world leading at the time. Unfortunately, it kept blowing up and breaking down because it was a bit too new. And then new wind farm went in. They were still only getting sort of 30% renewable contribution with a huge amount of wind that was feeding into the system. So our project was really designed to bring that from 30% to 65% just by adding enabling equipment. So that was things like batteries and flywheels and a resistor and a smart grid for that too. So yeah, that project proved all of that out, and it produced an extremely robust power system there that was able to run on 100% renewables at times. So that was an excellent outcome, and it was really great to see Hydro Tasmania take a leap like that, because it's quite a risky sort of project, that one. A lot of help from Marina. And yeah, then we took that technology and that business model and ran it through a bunch of different islands around Australia, in the Pacific. Yeah, building batteries in lots of places, building flywheels in lots of places. Yeah, it was amazing.
And some of that knowledge will be available for others to take part of too, I would imagine, through the knowledge sharing program with Arena.
Yeah, so that's definitely part of it. The other part, of course, is that all of the people who worked on it are still in the energy industry, and they're taking their learnings and putting it into their projects. And as the big grid transitions to similar sorts of renewables, all of the lessons that we learnt on that small grid are playing out in the big grid too. So it has helped speed things along. Yeah, for sure.
And I would imagine too that so like back around 2011 and around that time, looking at energy storage and battery technologies would have been quite a different experience from what it would be today. I would imagine you're like, in terms of the technology options, the maturity. Do you remember what kind of solutions you were looking at the time and what you ended up with?
Yeah, I'll start with the vanadium redox battery. So I was tasked with trying to fix that. The issue was that the inverter was a 200 kilowatt inverter made by a university, because that's how you got inverters at that time. It did not like the salt air in King Island, and every few months it would explode and you would have to replace the IGBTs and things like that. So that, and also the vanadium electrolyte side of things, we kept damaging the cell stacks, and it was just getting too hard to maintain. So we got to the point where we could not fix it. Like, we couldn't get support, and we actually had to dispose of it as hazardous waste, which was a bit of a sad moment. But it did highlight where batteries were at that stage. That was around about 2003 that it was installed, and it had just been sitting there idle for a very long time.
Oh, okay.
My project was for the King Island battery was when lithium was just starting to get a foothold. So we had a good range of responses from lithium companies to install batteries there. We ended up going with an advanced lead acid battery using a CRRC technology, which was a very good technology. And one of the big risks at the time actually was fire. So there was two big risks. One was fire, and one was a battery that didn't work. And just as we were building it, there was a really big fire in Hawaii for a similar battery. So
yeah, okay. Correct me if I'm wrong, but was that battery from a company called eColt? Was that the one who got spun out from a CSIRO arrangement?
Yeah, so the battery we installed was from eColt, which was an East Penn company. That's not the battery that caught fire. That was a different company.
Yeah. No, I didn't want to get any trouble here. No.
Yeah, so advanced lead acid, it was massive. Like, it was 11 shipping containers worth of batteries in a massive building. And the inverter was 3 megawatt inverter with a transformer. That was massive as well. Ended up being many millions of dollars to install. And interestingly, by the time we had built the project, a large proportion of the companies that tendered for it had already gone bankrupt.
Yeah, okay. Yeah.
So that was the environment we were in at that time.
Yeah.
But then it was only 3 years later when the Tesla big battery was built in South Australia as well. So that was the trajectory that they were on. We went from this small battery, it was 1.5 megawatt hours, to that Tesla battery, which is over 100 megawatt hours.
Yeah, it's amazing. And now, you hear announcements, perhaps not every week, but at least every month, of hundreds of megawatts of battery projects being secured or coming online and getting approvals. So it's a very exciting time in the
2.4 gigawatt hours, I think, is the biggest one so far.
Yeah. We've got a couple of big ones just around the corner down here in Geelong, and we've got the Victorian Big Battery, which is soon getting a big brother, I think, right across the road for Victorian Big Battery 2. So it's a lot of exciting development at the moment across the country. And so, and I would imagine too then when you applied those microgrid learnings into other islands and other parts of the world, you started looking at obviously different types of technologies, perhaps then the ones you started off with and the ones you did on King Island, or did you take it on a case-by-case basis?
Yeah, it was very much case by case. So a lot of the projects in the Pacific Islands were being run through the Asia Development Bank. So they had a very transparent tendering process. So pretty much every project had a different supplier at that point. And that was partially because there was so much competition in the space and the prices were coming down quite quickly, that the company that tended to win was the one that had just updated their battery price most recently. So it did flip around quite a lot at that time. And they were still small, they were still a few megawatts.
Yeah, okay. Yeah. I would imagine today and the last year or two, there would have been a lot of that happening in Australia as well, with around the world with battery pricing being on a very interesting trajectory, particularly for the typical ones like LFPs. It's been very interesting to see from the sidelines.
Yeah, there's a lot there for sure. There's a lot of change that's still coming through.
Yeah, and it'll probably take a while, right? And there's obviously a lot of other pieces and components in a complex grid scale energy storage systems than just the cells and the packs. But yeah, it will have a fairly big impact, I think, over time.
I think that's actually one of the strongest parts of batteries, is that how modular they are. Once you start talking at a few megawatts, the solution doesn't really change appreciably. It's just how it's connected to the grid that matters.
Yeah. And so these days you're the head of energy for CRRC Times Electric Australia. And I guess for people that don't know about CRRC or the Australian business, can you tell us a bit about the organization and the type of capabilities and projects that you guys are involved in?
Yeah, sure. I'll start with the Australian business first. So we're a subsidiary of the Chinese business, essentially. And we were set up mostly to assist in the Melbourne Metro train project. There was 70 CRRC trains that were being built through that project. And the intention was to maximise the local content when the Victorian government awarded the work. So the focus of our business for the last 6 years has been to make the tractor inverters for those trains in a facility that we have in Morwell in the Latrobe Valley. That site was chosen with the help of the government to help deal with some of the lost jobs that came out of the Hazelwood closure. Like, it pretty much ripped the heart out of that town. So having some manufacturing work in that area was seen as extremely important. A tractor inverter is essentially a large inverter that sits underneath the train and runs the motors. So it's the manufacturing side of things was essentially you take a large metal box, which came from China, and then you fit a huge amount of electronics into that space, and all of the cooling and everything that goes with it, all meeting the very stringent rail standards. It's very obvious when a train doesn't work, and it has some pretty big consequences too. So it's, that manufacturing plant ran flat out for 5 years. And just this year stopped producing those inverters, and it has since entered their maintenance mode. So they've got another 35 years of maintenance as those trains are commissioned and put into service. So we're getting a few inverters back at the moment, mainly from the trains hitting things. But so that's essentially what our business was established in Australia for.
Yep.
CRRC generally, so as a corporate entity, it's huge. It's got nearly 200,000 employees.
Wow.
Yeah. And its focus for a long time has been on the Chinese market because it's the world's largest manufacturer of cranes in the world. And for a long time now, they've been investing in other products, and it's mostly in the new energy space. They've been building wind turbines for a long time. They make a full wind turbine, all of the components, as well as supply some of the other wind turbine companies, solar inverters, more recently batteries, EVs, EV drivetrains, I should say, from small cars all the way up to big industrial vehicles like mining trucks and trains. So that business has been focused in China for a really long time. And CTA, which is the Australian business, was one of their first forays into manufacturing in other countries. And it's been very successful in that they're really keen to take what they've learned and then the products that they have and start seeing how it fits into international markets.
Yeah, awesome. And we're looking at potentially utilizing that existing manufacturing facility in Morwell for other things, like as in energy products and things like that in the future.
Yeah, that's the idea. Particularly the battery inverters and the solar inverters and some of the similar products like that are perfectly suited to that facility. One of the strengths is that we can just take a manufacturing line out of the Chinese facility and put it into there with almost no overhead and start producing it in Australia. We can do that very quickly. For the Metro Chain project, it took 6 months to go from making the decision to do it and to actually be making things in the factory.
Wow, that's awesome. And what kind of products are you looking at introducing into the Australian market over the next few years? You're obviously a background in energy storage and solar, and what kind of things are you looking at bringing in, and what are you most excited about?
The potential for batteries is huge. Like Australia has led the way in batteries for a long time now. I think because we've been doing it for so long, we're a bit blasé, I think, about the scale that things are at and how much the world is going to catch up. In terms of an international growth, batteries is really important, and the CRRC products are good and hit the right price point and things like that. So that's where I think a lot of our focus will be in Australia and internationally for a while. We do have... It's the largest battery developer in China too. So it's a pretty big pipeline that's already there. The other area that we're having some pretty interesting success in is the industrial EVs. So that's things like trains and, like I said, mining trucks and bigger vehicles, converting those to battery electric or some hybrid of that, either through retrofits or new vehicles. There's a lot of interest in that space. There's been a lot of talk for a few years now, and the rubber's starting to hit for a few of those. It's one of the flaws, I think, of the way the energy transition is discussed, because we often just talk about the grid and how we're getting from 0% renewable to 20 and then 50. And that discounts the fact that that's only about a third of the energy that Australia uses. So things like fuel is another third. So being able to decarbonise that is really important. And then there's even the more tricky ones like gas that also come through. So all of those means of electrification are really important to focus on. And obviously the ones that are easier you do first. So that's why EVs are doing such an excellent job at the moment. That pushes into bigger vehicles. And hopefully at some point in the future, we'll be talking about how we swap out a gas furnace with an electric powered furnace.
Yeah, absolutely. Yeah. Just have another question, just more broadly about the technology landscape we're in around the energy transition. What do you think are the most exciting new developments that are on the horizon coming soon in the energy space that will change the game?
It's a good question. So hydrogen's been sitting there for a while because I've had this longer history with hydrogen. I've seen how it can stop and start. Back in the sort of mid-2000s when we were looking at it, it looked like it was going to be big. You just had to produce it at the right price, and petrol had to be at the right price, and then it would be good. Became very clear very quickly that wasn't going to happen. So that's why everyone dropped it quickly. There was a lot of hype for hydrogen 2 or 3 years ago, with some really big projects announced, and then I think everyone realised how hard it would be, and it slowed everything down. We can see a lot that's happening now that are a lot more sensible. People are put more thought into their ambitions, and there's some good projects coming through. I'm really interested to see how they play out, because if that is cost effective, that will change things a lot. If it's not, then we'll have to essentially go back to the drawing board for a lot of our decarbonisation plans, particularly things like green steel and those elements. Yeah, I really hope that one comes along, and it will change things if it does. But in my view, the jury's still out on it.
Yeah, I guess we're finally starting to get to a point where some of our grids, or part of our grids like South Australia, we're starting to get to a point where certain times of the year we'll have so much excess renewables being spilt or not being utilized that we're also starting to see a real shift in available surplus solar and other renewable electricity, which I would imagine will impact the economics greatly as well for those type of technologies.
Yes, that's a very important part of it. But I do have a story that might show you the other side of that coin.
Yeah, I love to hear it. Yeah.
So King Island, like I said before, it had a lot of renewables on the system, and we installed a bunch of enablers to increase the renewable penetration of that system from 30 to 65%. That was really about capturing that spill that we had to waste energy because we couldn't fit it into the power system. Yeah. And one of the ways that we did that was, instead of wasting the energy at the wind turbine by changing the pitch of the blades, we would burn it in a resistor. So that resistor was big, like it was bigger than the load of the island. And whenever the wind speed was variable, which is nearly always, we would use that resistor to regulate we would load it up and then use it to regulate the grid. So that meant we were wasting really large amounts of energy, but because it would have been wasted anyway, it was okay. We went to a lot of effort to try and find a good use for that energy. There was thermal storage that was looked at. It was really hard to make work. All the sorts of use cases you would think of that you would be like, energy on King Island is expensive and here's free energy that we're offering. We just couldn't do it because of the capital costs. The capital cost of something that's so, like, the resistor would run for a week and then it would not run for a week, sort of thing. Recouping the capital investment was actually the hardest bit.
Yeah, gotcha. Interesting. And I remember having a look at your kind of the type of technology that CRRC is deploying or starting to deploy in other parts of the world, like China. One of them being around the high voltage batteries. Is that something that you think we'll see in Australia and other parts of the world too over the next few years?
Yeah, I do think there's a huge amount of potential in products like that. My knowledge is not quite good enough, I think, to really talk too much about where it will lead. But essentially, it's a solid state transformer is the way I picture it. So instead of you needing to have a big transformer with all of its copper and oil and all of the stuff that you need to make that work and buzzing away using energy, you use the power electronics that are in a normal inverter to essentially boost your voltages up to a grid connected voltage. From a battery point of view, it means that you don't need the transformer, and it means that the battery can offer a lot more services to the grid than it otherwise would. It does have potential downsides too, like harmonics, but from a broader sense, if that technology works, then that means that transformers can be done with power electronics. You don't need a transformer, which means that they can offer a lot of services in the network as well that they currently can't, because they're a big thing that occasionally explodes. So yeah, that will change things. It will definitely make it a lot easier to integrate energy into grids, particularly smaller batteries. So you'll be able to just essentially, instead of a community battery that there's a lot of effort to integrate it, you could potentially just put it down on the ground somewhere and wire it in to the system as a full modular unit.
Yeah. Fascinating. I'm sure we'll see plenty of other interesting technologies too that will surprise us over the next few years. But I think that's probably all we got time for today. Great to pick your brain. Great to have a conversation, and I'm sure we'll chat again soon. Thanks, David.
No, thank you. This is a very interesting conversation, and I really enjoyed it. Thanks.